Hello, everybody. Welcome back. Today we're going to be looking at part 2 of this introduction to organic chemistry. So I hope you've watched part 1. It'll make a lot more sense if you have. So let's get started. All right. So last time in part 1 of this introduction to organic chemistry, we looked at a family of hydrocarbons called the alkane family, and they are characterized by carbon chains that have all single bonds. And the word we used when we were talking about alkanes was saturated. The term saturated in organic chemistry implies all single bonds saturated with hydrogen. So then the question is, well, what if your carbon chain has a double or a triple bond? If your carbon chain has a double bond, we don't call it an alkane, we call it an alkene with an E. And you'll notice there, let's think back to part 1. When you are given a structural drawing and you are asked to name it, the first thing you want to do is find how many carbons are in that longest consecutive chain, and that will determine the prefix that we use in the name. So I see 3 carbons and I think in my head, okay, meth, prop. The prefix for 3 carbons is prop, but we don't call it propane. Because there's a double bond, it gets an ENE ending, we call it propene. If it has a triple bond, it's not an alkane, it's not an alkene, we call it an alkyne. And once again, I'm going to count my carbons. I see 5. The prefix for 5 is pent, so it's pentyne. Now I want you to notice that there is a number 2 in the name. And if you think, what that 2 might be referring to, it indicates where the triple bond is located. It is located on the second carbon. And let's just remember back to the first part of this lesson on organic. You want to number your carbon chain. Could be from left to right, could be from right to left. You want to decide on your numbering system so that you get the lowest possible number. So based on the fact that they're calling this 2-pentyne, indicates to me that they have numbered from right to left. Okay, so that would be 2-pentyne. Now I imagine if you put the triple bond in that position, it would still be 2-pentyne. We would then number from left to right. Now, what if we put the triple bond in that position? Then it would be 1-pentyne. Okay. All right, so depending on if it has a double or triple, it gets that ene or ine ending. Okay, and if you're wondering, how do I know if I need to indicate a number in the name to tell me where the double or triple bond is located? That is only necessary if your carbon chain has more than 3 carbons, so 4 or greater. You need to put a number in the name indicating where that multiple bond is. So for example, this one in front of us, I see 4 carbons. The prefix is bute. It's a double bond, so it's butene, and we have to identify where the double bond, so it's 1-butene. Okay, this is just another example. And the next thing that I want to talk about, make a note, this concept of something called cis versus trans isomerism. This is a concept that applies to alkenes only. Okay, write that down. All right, alkenes only, meaning there's a double bond. Okay, and it's not even all alkenes. All right, but I want you to look at these images in front of you, and I can see that both of them, the longest carbon chain has 4 carbons, so the prefix is bute. Both images have a double bond, so it's butene, and both of them, that double bond is coming off of the second carbon, so they are both 2-butene. However, look at the difference. Okay, let's look at where do the ends of the carbon chain end up. Okay, so in this image on the right, the ends of the carbon chain end up both on the top. Okay, so both of these structures on left and right have sort of this X shape to them. Okay, and the image on the left, the ends of the carbon chain end up both on the top, whereas the image on the right has the ends of the carbon chain starting out on the top, but then it ends on the bottom. If the ends of your carbon chain end up both on the top or down here, if they ended up both on the bottom, same side, that is considered a cis isomer. Whereas the image on the right, it starts on the top but it ends on the bottom. That's called a trans isomer. It would also be trans if it went in that direction as well. If it starts on the top, ends on the bottom, starts on the bottom, ends on the top, whatever, that's a trans isomer. Okay. Now, if any of you take organic in college, your professors might use terms, they may use these terms boat and chair geometry, and that seems really silly, but when you have cis isomers, this is what they would call boat geometry. So imagine, you know, here's your little flag, and here's you, and you're standing in the boat, and here's the water. Okay, that's boat geometry. Whereas the one on the right, if you think of it, it's not so much of a chair, it's more like a recliner, you know, and here's you, and you're taking a little rest. Okay, that's a terrible drawing. All right, but you may hear those terms, boat and chair, and it's connected to cis and trans geometry. But again, cis and trans isomerism, that is only applicable to alkenes. Now, do all alkenes have cis and trans in their names? No, they don't. Okay. I want you to look at the image in front of you for question number 2. All right. You have a structural drawing drawn in, and I can see that this drawing has sort of this X shape, and that's a clue. Hey, you need to include cis and trans in the name. But like, look at number 1. I see a double bond. It's definitely an alkene, but I don't see that X shape, so you do not need to include cis or trans in the name. Okay, so what we're going to do, we're actually going to do one together. We're going to do number 2 together. We're going to talk this out, and then I'm going to have you try these on your own. But let's talk through number 2. And remember, regardless of what type of molecule it is, the first thing you always want to do is find that longest consecutive chain of carbons, and maybe it'll be helpful if I sort of outline that chain of carbons. Okay, and now let's count how many carbons are in that chain. I count 1, 2, 3, 4, 5, 6, 7. Let's think, what is the prefix for 7, everybody? It's hept. It's got a double bond in the main chain, so it's heptene. All right. Now, let's think, do I need to include a number to tell us where that double bond is? And the answer is yes, I do. Remember, the rule is if your main chain has 4 carbons or more, and you have a multiple bond in there, you need to indicate where that double or triple bond is. So let's decide, do we want to number this chain from left to right or right to left? Which direction is going to give us the lower number for where that double bond is? And it looks to me like it makes more sense to number from left to right. So I'm going to call that carbon 1, 2, 3, 4, 5, 6, and 7. So where is that double bond? It is on carbon number 3. Okay, now, what is going on here? Like, what is this? If you remember from the part 1 of this organic lesson, what do we call anything that is attached to our main chain? We call them substituents. This substituent has 1 carbon, so if you will recall, we call that a methyl group. And we do need to indicate where it is. It looks like it is attached to carbon number 3. So let me see if I can space this out just right. So we were going to call this 3-methyl 3-heptene. Okay. Our final thing that we need to address, because it does have some cis and trans isomerism going on here, we need to indicate, is it cis? Is it trans? The ends of the carbon chain appear to both be on the bottom side of that X shape. So, ladies and gentlemen, that is a cis isomer. Now, let me just say one thing before I let you try some on your own. Every textbook is a little bit different as to where the cis and trans is put into the name. I've always been taught to just put it right at the beginning of the name. You can see in number 5 that I've got a trans isomer, and I put the word trans right at the beginning. Some textbooks have you put it closer to the end of the name. I'm not sure it really matters. This is just how I am accustomed to doing it. So what I would like you all to do at this point is to pause your video here, see if you can name number 1, and then 3, 4, 5, and 6, I want you to draw it out in whichever way is easiest for you, and we will check your answers and see how you did. All right, let's see how you did. And again, we were naming number 1, we already did number 2, and then you were drawing out 3 through 6. So let's see how you did. Okay, so there's the answers for the names for 1 and 2. And I have drawn out 3 and 4. Notice a little difference in how I drew them out. In number 3, I drew out every single atom, every single bond, and you can certainly do that. If you feel like you're getting the hang of knowing how many hydrogens each carbon's going to have, you can draw a little bit of a more condensed drawing like I did in number 4. Okay. And let's look over to numbers 5 and 6. 5 gave us a trans isomer, so I needed to make my drawing have that sort of X shape. Okay. And in number 6, there's our alkyne. Right? So hopefully you did all right on those practice questions. All right, so one thing that you may also see in drawings in organic chemistry is a specific molecule called benzene. It comes up a lot. It comes up a lot in compounds that tend to have strong odors or smells. Many compounds that have a strong odor are benzene-containing compounds, and this is what benzene looks like. It's a 6-carbon ring, and this image on the left was taken from the textbook that I use, and there's just something about it that I'm not super crazy about. Benzene is a 6-carbon ring, but, and I'm going to draw this in, benzene has double bonds on every other side, which is why each carbon, if you look in the drawing, you see that 120-degree bond angle, that sp2 trigonal planar shape, okay? And since benzene is such a common compound, and organic chemists are doing a lot of drawing, they like shortcuts. So if you look at this image in the middle, you will see benzene often drawn just with a symbol that looks like that. Bit of a shortcut. And if you'll notice in that image in the middle, B, letter B, it's showing two different images. Do you all remember the concept of resonance? Those double bonds can be on alternating sides. So benzene does experience resonance. And because even drawing those images in the middle in letter B is just apparently just too much, you will often see this symbol drawn. And that is the international symbol for benzene. So I just wanted you all to be aware of what benzene is because you tend to see it frequently in organic chem. So the final thing that we're going to get into is a group of things called functional groups. And they are sort of like substituents. They're things attached to our hydrocarbon chain. However, they are things attached to our main carbon chain that make the molecules so different and alter the chemical properties so much that it's really more than a substituent. It's something that changes the whole nature of the compound. And we're going to look at 6 functional groups. And the first thing that I want to say on here, anytime you see on the next 2 slides the letter R, I'm hoping we all have been through chemistry and we know that there is no element R on the periodic table. I am using R to mean the main hydrocarbon chain. Okay, whatever that is. Is it an alkane, an alkene, an alkyne? Is it a cyclic molecule? Whatever. I'm meaning the main chain. Okay, so let's look at this first one. It's a class of molecules called alcohols, okay? And if you look at that general formula box, it's showing that an alcohol is defined as any kind of hydrocarbon chain that has an OH, a hydroxide group, joined on to it. So, for example, let me get to a fresh page here. Let's say we had a 5-carbon chain, and I'm just going to draw the carbon backbone. And to that carbon chain, I had an OH group on the end. We're going to go through the same thought process. We count how many carbons we have. I see 5, so that's pent. It's all single bonds, so pentan. And if you go back to that previous screen, when it is an alcohol, which I can see that this is, it gets an OL ending. This is a molecule called pentanol. All right? And we do need to indicate where that OH group is attached, because an alcohol can have an OH group attached anywhere. It doesn't just have to be on the end. So I'm going to name this molecule 1-pentanol. Okay. If I move the OH group to the second carbon, I would call it 2-pentanol. Okay. So we need to indicate where that OH group is, and that's what makes something an alcohol, right? Let's look at the next one. They're called ketones, and let me help you understand what's going on in that general formula. In the middle of the carbon chain, okay, so not at the end, but somewhere in the middle, we have a C double bonded to O. So for example, let's say I had something like that. I see 4 carbons, 1, 2, 3, 4, meth, eth, prop, bute. Okay. The carbon chain has all single bonds, so butane. And there is a double bonded oxygen to one of the carbons that is in the middle. That's really important, that it's bonded to one of the carbons in the somewhere in the middle of the chain. That makes it a ketone. So this would be called butanone. Okay. Now, do I need to indicate where that C double bond to O is? Well, for this example, no, I don't. Okay, and I'm going to show you one where I do need to indicate that. Imagine if I move this C double bond to O to right there. Well, now it would be on carbon number 2, but come back to where it was before. Isn't that on carbon number 2 as well? We would just number from the other direction. And you might say, well, what if you put it here? Well then, guys, it's not a ketone then, because a ketone has a C double bonded to O somewhere in the middle of the chain. Okay, now, when would be an example when I do need to indicate where that C double bond to O is? Let me do this. Well, now it's got 5 carbons. Okay, it is a ketone. That C double bond to O is in the middle of the chain, but now I do need to indicate where it is, and it is on carbon number 2, 2-pentanone. Would the name change if I move it there? Yes, it would. That would now be not 2-pentanone, but 3-pentanone. Okay, well, what if I put it there? Well, now we're back to 2-pentanone. Okay, so ketones, sometimes you need to indicate where that C double bond to O is, and sometimes you don't. It basically depends on if you were to move it to a new location, would that change the name, yes or no? Okay. Now, ketones, as we just said, have a C double bonded to O in the middle of the chain. Well, what if it's not? What if it is at the end of the chain? Well, then it's not a ketone anymore. It's something called an aldehyde. So let's say I have a 5-carbon chain, and to the carbon on the end, I have a C double bonded to O. This is not a ketone because that C double bonded to O is not in the middle, it's at the end. So I get this pent prefix, pentane, because it's all single bonds. Okay, and aldehydes, sort of similar to alcohols, they get an Al ending. Don't confuse that with Ol for for alcohols. This is pentanal, all right? Now let's think about how the name would change if I did this. What if I threw a double bond into that molecule? Well, the only thing that's going to change, guys, is it wouldn't be pentanal, it would be pentenal, because that E indicates that there's a double bond. Now, do I need to indicate where that double bond is? Yes, I do. Remember, guys, the rule for do you need to indicate where a multiple bond is? The carbon chain, if it has 4 or more, then I do. So this is 2-pentenal. Okay. And a question that I get a lot is, how do you know if you need to indicate a number in the name for where the functional group is? And it kind of depends. Like alcohols, we definitely do. Ketones, we sometimes do. Aldehydes, we don't, because aldehydes have sort of a fixed position. Aldehydes, that C double bonded to O, that functional group is always on the end. Okay. If your functional group can be in different locations, then chances are you do need to indicate a number for where that functional group is. Be aware, my students, I am not going to give you any examples where you have to not only indicate where a functional group is, but also put a number in for a multiple bond. That's sort of above the pay grade of this class. So I won't do that to you. Okay, we've got 3 more functional groups. The 4th type of functional group, it's called a carboxylic acid. And I want you to look at that general formula. Much like aldehydes, this is a functional group that will always be found on the end of the carbon chain. Okay, but it's not just a C double bonded to O. It's a C double bonded to O with also an OH group attached. So let's say we have something like this. Okay. This is definitely a carboxylic acid. I see C double bonded to O and an OH group, and it's on the end. It's attached to that first carbon. Let's count the carbons: meth, eth, prop, bute, butane, because it's single bonds. And carboxylic acids get an ending that looks like this: butanoic acid. Okay, and this hydrogen right on the end, that is the acidic hydrogen. Remember, we've done acids and bases. Acids will donate away a hydrogen ion, and that's the one that it's going to give away. And I'm sure I don't need to tell you this, but carboxylic acids are all weak acids. None of them are, fall in that category of our strong acids. All organic acids are always going to be weak acids. Okay, so this is what a carboxylic acid looks like. These last 2 are much simpler. An ether, okay, if you look at that general formula, it might look a little odd. What we have with an ether is an oxygen that's not attached to the main chain. It's actually interrupting the main chain. It's in the middle of it. So let me show you what that would look like. Maybe something like that. It's not attached to the main chain, it's part of the main chain. It's interrupting. And what you do with an ether is you treat the either side of that oxygen, the things attached to that oxygen, sort of like substituents. For example, what is a 2-carbon substituent? How do we name that? We call that an ethyl group. On the right-hand side, a 3-carbon substituent, we would call that a propyl group. And then it's simply a matter of which comes first in the alphabet, E or P? E does. So here's the full name. Ethyl propyl ether. You name the sides of the oxygen kind of like that they are substituents, and then you tack on the name ether. If that word ether sounds familiar to you, if you're a history buff, you may have heard of ether before. Ethers were used at the beginning, the early stages of surgical anesthesia. Ether is a very volatile liquid. It evaporates very easily. And sometimes if you've ever seen a picture or an image from some of the earliest days of surgical procedures, you'll see the patient with either a cloth or a cone over their mouth and nose, and the nurse would pour ether, this liquid ether, over the cone. The patient would inhale the vapors and go into unconsciousness. Now, they don't use ether anymore. As an anesthesia, it not only has some negative side effects on the patient, but it's also extremely flammable, and so it was causing fires in the surgical procedures and in the surgical theaters, and that was not a good thing. Okay. So let's look at this last one. They're called amines. And if that term amine is a little bit familiar to you, especially if you have a biology background, you might think like amino acids, like amino acids. Amine means nitrogen containing compounds. So this is an amine, and an amine is if you have an NH2 group attached. Doesn't have to be on the end, could be anywhere. So let's look at an example like a 3-carbon chain with an amine group on the end, meth-eth-prop. All one word, propylamine. Okay, so you just name the carbon chain that's attached to it and throw amine on the end. And if that ending, that amine ending right there, if that's familiar to you, it should be. There are things that we hear about in our everyday lives that end with amine, like methamphetamine, okay, is an amine. Or if you have an allergy to something, that triggers the release of histamine in your body. Okay, so you have likely heard that term before, even if you didn't know what it was. So guys, let's wrap this up. Could we give you, in organic chemistry, could we give you a molecule that has a functional group? Maybe it also has a double or triple bond, and maybe it has some substituent groups, including halogens attached. That's something pretty common. You'll sometimes see chlorines or bromines or iodine atoms attached like substituents to your main chain. Could we throw all of this at you? And the answer is absolutely yes, we could. So we're going to do some practice of putting this all together. But the key thing is, let's say you have a molecule with a functional group, with a triple bond, with substituents. How do you know how to number your carbon chain? Lower numbers are best, of course. And ladies and gentlemen, the importance of what should be on a low number carbon is in the order you're seeing on the screen there. Functional groups, carboxylic acids, alcohols, ketones, aldehydes. These things are the chief in importance for being on a low number carbon. Next in importance is your double or triple bond. And the last thing, the thing that is the least important to be at a low number carbon, if you have all of these boxes being checked here, are your substituents. So what I'm going to do on the next couple of slides is I'm going to throw some molecules at you that have all of these things, and I want you to think about how you would name these things, these molecules. So here we go. Here is your first one, okay? I want you to pause your video and see if you can handle naming this compound. All right, ready for the big reveal? Let's see how you did. Okay, so there's the answer. Let me talk it through a little bit. So the first thing I noticed was that my main chain had 7 carbons, so hept. I saw a double bond, so heptene. And I saw a functional group on the end. That is a carboxylic acid. So it gets that oic acid ending, heptenoic acid. Now, do I need to indicate a number for where that functional group is? The answer is no, because carboxylic acids are always on the end. However, that is going to dictate my numbering system. Remember, functional groups are the most important to be on a low number carbon. So that carbon on the far right, that is carbon number 1, 2, 3, 4, 5, 6, and 7. Because this carbon chain had more than 3 carbons, I needed to indicate where my double bond is. That's why the number 4 is in that name. And then I had to indicate where my my substituents are. There's an ethyl group, there's a methyl group. So this is my final answer. Okay. Let's look at another one. All right, here's your next one. You all enjoy this one. Pause your video, see how you do. All right, let's see how you did with this one. Okay, so again, first things first, you always want to count how many carbons are in your longest chain, and I counted 9. So there's that prefix non. It's got a double bond, so nonene. And right here, there's a functional group. Now that kind of looks like a carboxylic acid, but it's not. It is an aldehyde, which is why it has that al ending in the name. Okay, now, much like the carboxylic acid, do I need to indicate where that functional group is? And the answer is no, because again, aldehydes are always at the end. However, that will dictate my numbering system, because this has to be carbon number 1. Functional groups are the most important thing. So I can number starting there. 7, 8, and 9. Okay, so that number 5 right in front of noni now, that's telling me where my double bond is. I have to indicate that. I've got a substituent right here. It's an ethyl group. It's on carbon 5. And look at where the ends of the carbon chain are. That starts on the top, it ends on the bottom. That is a trans isomer. All right. I've got one more for you. I think you're going to like this one. Try this one. Pause your video. See how you do with it. Okay, last one. Let's see. All right, so this is a cyclic molecule. It's not a main carbon chain, it's a shape, and it's got 5 carbons. So that's cyclopent. Now it has a triple bond there, so cyclopentine. And ladies and gentlemen, I see a functional group. An OH group indicates an alcohol, so it's cyclopentanol. Now, are alcohols, do they always have an OH group at the end? And the answer is no, they don't. But a cyclic molecule doesn't really have an end. It's like saying, where is the end of a circle? There isn't one. So when I'm trying to decide how to number my carbons, if it's a cyclic molecule, I want to put that functional group on carbon number 1 because I can. Okay. Now, what's next in importance? Remember, is a triple or a double bond, a multiple bond. So does it make more sense to number clockwise or counterclockwise? It makes more sense to number counterclockwise because I want that triple bond to be on as low a number carbon as possible. So I'm going to number counterclockwise so that that triple bond, is on carbon number 2. And then I've got a methyl group and I've got a chloro group. If you ever see halogens, you name them with this O ending: chloro, bromo, fluoro, iodo. Okay, but you treat them just like substituents. Okay, and I've only put the chlorine first and the methyl second because I went in alphabetical order. So guys, I realize there is a lot to think about there, but these are some pretty challenging examples that I wanted you to try. Okay, so this is just an introduction to organic chemistry. This is basically just the simple nomenclature, the simple drawing. This is enough that if you were to sign up for an organic chemistry class in college, you would at least know a little bit of what's going on for maybe the first couple of weeks when they talk about the nomenclature and things like that and the drawing. Much of organic, of course, is a lot to do with the reactions, which they don't even call reactions, they call them mechanisms. And it can get very, very complex. So this is just scratching the surface. So I hope you all have learned a little something, and I look forward to seeing you next time.